Hey everyone, one more video on finding inverses. We looked at finding the inverse of a quadratic function, and that's a little tricky because you can actually only look at half of a parabola if you want to find the inverse. And that ends up showing up as when you do the algebra, you'll get a plus or minus on the square root, and you have to choose the appropriate one to go with the half of the parabola you're working on. There's a little bit of trickiness that also comes up with square root functions. It's related, but I think it's a little more hidden and a little less confusing to people once they catch on to it. So I want to work on this function p of t equals the square root of 3 minus t plus 2. First thing I want to do, because domain restrictions are important for these, is figure out the domain of p. So I want to make sure that 3 minus t is greater than or equal to 0, since I'm trying to take the square root, which means t has to be less than or equal to 3. So 3 greater than or equal to t, or t less than or equal to 3, same thing. Okay, so let's go ahead and do the algebra. So I'm going to say I had a y equals square root of 3 minus t plus 2. To find the inverse, I switch the variables, and then I solve for y. So I'm going to get rid of the last thing first. So order of operations, if I plug in a number for y, I'd multiply it by -1. I would add that to 3. I would take the square root of all of that, and then I would add 2. Since that was the last thing being done, it's the first thing I get rid of. So subtract 2 from both sides. We then need to square both sides of the equation to get rid of the square root. We can then subtract the 3. So I have a t minus 2 squared minus 3. And then multiply everything by a -1. So negative t minus 2 squared plus 3 equals y. Really careful on that multiply or divide, whichever way you want to think about it, by -1. There are two terms here separated by this subtraction. You can't distribute the -1 into the parentheses because you'd have to first square it. You do want to make sure that you multiply the -3 by -1 as well. If you'd like to square at this point and then distribute the negative sign and then add 3, you can do that. I actually find that that makes it a little harder if you want to check whether the two functions are inverses, so I didn't ask us to do that here. But I would say it's easiest just to leave it in this form. You have the 1t, and you can see each operation that happens to the t. So I'm just going to say p inverse of t is equal to negative t minus 2 squared plus 3. Okay, so here's the little bit of trickiness. If we start with a quadratic, we have to split it into half of a parabola before we can even get started, because an entire parabola does not have an inverse. When we start with square roots, it's a little bit more hidden. The problem is that we did all this algebra and we got an entire parabola, and an entire parabola can't possibly be the inverse of just this one little square root function. So let's see if I can give you a rough sketch of what this looks like. Okay, so we have our square root function. It's reflected across the y-axis, and then it's shifted to the right 3. So just to make sure everyone sees this, it's like having a negative t plus 3, and we would have to factor here. So negative t minus 3 plus 2. Okay, so flip across the y-axis and right 3, and then up 2. So it's going to open this direction, and its endpoint is going to be at 3, 2. Okay, so just rough sketch looks something like this. Which means when I flip across the line y equals x, I should get something. I actually think what's happening here is that these 2 points are really close, but it heads out this way. Let me show you on my calculator, because I don't think that's looking all that easy to follow. Okay, so if we go through here, y equals x can stay, that's fine, and we graph the square root of 3 minus x plus 2. There it is. And there's y equals x. So when we flip, we're going to get something that matches up fairly closely. It's not spot on, but fairly closely, and then heads out this direction. If you're interested, you can even get your calculator to draw a picture of the inverse for you. So if you hit second program, you'll get draw. It says draw right above the program button. Let's see if I can spot it. Draw inverse. There is kind of a tricky part. In order to tell your calculator to draw the inverse of that function we were looking at, you have to tell it where in your y equals you entered that. So I entered mine into the very first spot, y1. To get y1, you have to go into variables and then over to y variables. So hit the VARS button, over to y variables. We're working on functions, and there's the y1 right at the top of the list. If you go in, it'll show you. So kind of what we were describing. The answer that we got is an entire parabola, and what we really want is only half of a parabola. So right here I have a parabola that shifted right 2 and up 3, and it's upside down, so it's going to open this direction. So it's going like this. And I don't want the whole thing. I only want, in this case, the right-hand side of it. So I have to force the domain restriction onto this function. I want only t's greater than or equal to 2. Remember, again, a good way to figure out your domain restriction is if you can figure out the domain and range of this function, the range of p will be the domain of p inverse. So if you figured out a good graph of p and you can see that your y has to be greater than or equal to 2, that automatically means here that you need to choose t greater than or equal to 2. I won't even let you just space out and miss this. On a problem like this, I would pretty much always ask you to state the domain. So even if you forget to go check this, I'm hoping that that will catch you and you'll realize that you need a domain restriction. So an entire parabola should never be part of an inverse problem. Okay, the other thing I want to do with this one is just look at a few values. So if we find m of m inverse of 4, oh, m, let's make those p's. P of p inverse of 4. Okay, so p inverse of 4, we're doing a baby check here. We're not fully checking the equations, but we're checking a couple of values. If I plug in a 4, I get 4 minus 2, which is 2. I square it, I get 4. Negative 4 plus 3 is negative 1. If I then plug the negative 1 into p, I get the square root of 3 plus 1, so the square root of 4, which is a 2, plus 2, which is a 4. This is wonderful. When you compose inverses, you're supposed to get back what you started with, so I like it. P inverse of p of negative 1. Okay, we've already done part of this work. We found that p of negative 1 was 4. So we need to figure out what p inverse of 4 is. And actually, we've already done that work as well. But if you want to see it again, 4 minus 2 is 2. 2 squared is 4. Negative 4 plus 3 is negative 1. And once again, this is a good thing. I got back where I started. So if I plug in a negative 1 to the composition of the function in its inverse, I should get back a negative 1. P of 4. Okay, so if I plug 4 into p, I actually get immediately stuck. 3 minus 4 is negative 1, square root of negative 1. Not okay with us. We're only doing real valued functions. I don't want an imaginary number here, so we'll just say undefined. 4 is not in the domain of function p, so we shouldn't be plugging it in the first place. So this does not violate the rule that says f inverse of f of x should equal x, because that rule has a little subtext to it that says it should equal x as long as x is in the domain of the inner function. So this is okay. Sometimes p inverse of p will not give you back what you started with if you start with something you're not supposed to. Okay, last one, p of p inverse of 1. So we plug 1 into p inverse. We get negative 1 squared, which is 1. So we have a negative 1 plus 3, which is 2. If we then plug 2 into the p function, we get 3 minus 2, which is 1. Square root of 1 is 1. 1 plus 2 is 3. We did not get back what we started with. So this is a bad thing. When you compose inverses, you're supposed to get back what you started with. But the truth is, this isn't saying that our functions aren't inverses. This is saying we weren't paying good attention. We very clearly decided that we should only be plugging in things bigger than 2 to P inverse. So I'm not claiming that this quadratic is always the inverse of the square root. I'm claiming that as long as I choose a t bigger than 2, it is. So really, we should have dead-ended right at the beginning and said, this is undefined because 1 is not in the domain of P inverse. Okay, so really watch those domain restriction things. Thanks for watching.